The question here says that 13.10 in exercise 13.9, let us take the position of mass where the spring is unstressed as x equals to 0 and the direction from the left to right as positive direction of x-axis. Now give x as a function of time for the oscillating mass. If at moment we start the stopwatch at t equals to 0, the mass is at mean position, at the maximum unstressed position and the maximum compressed position. So here we have to find out the three equation of motions of SHM for the given initial conditions as in the previous question. So now the varying thing here is that the initial position of the particle has been varied. In the first part, it is said that the particles, the mean position is the initial starting position. So like if this is the compressed position and this is the uncompressed position and this is the mean position. So the part of the question says that if the particle is at the mean position, then what is the equation, and if the particle is in the stressed position, that is in the B case, so what is the motion, and if the particle is in the compressed position, then what is the equation of motion. Now these three conditions, these three are the initial conditions, like the particle at t equals to 0 is at the mean position, and the particle at t equals to 0 is at the maximum amplitude position or the stressed position, and at the particle t is equals to 0, the particle is at minus amplitude position or the least distance from its base, or it at the maximum in the opposite direction, maximum position far away from the mean position. So we have to find out the equation of motion. So we have been given that angular frequency is 20 radians per second from the previous question, and maximum acceleration we found out as 8 meter per second square and Vmax as 0.4 meter per second. So the only thing we need here is angular frequency and amplitude. Amplitude is 2 centimeter. So when the particle is at the mean position at time t equals to 0, then the equation should evaluate to a or the amplitude at time t equals to 0. Now since sine with initial phase angle is at 0 at time equals to 0 will be equal to 1, so the equation fits here. Now the equation becomes 2 sine 20 t centimeter. Now at time equals to 0, if the particle is at the maximum stressed position, that is at x0, we have a, that is at time t equals to 0, it should evaluate to a, then we will get a cos omega t. Now the cos functions at 0 angle gives the maximum value, that is 1, so we can use a cos omega t over here with 0 initial phase angle. So the equation becomes 2 cos 20 t centimeter. Now the third part of the question, at maximum compressed position, that is x0 is minus a. So at this position we have again the at angle 0 cos gives the maximum value, that is 1, so minus a cos omega t will be the right equation for this question. Now substituting these values, a would be 2 centimeter and omega is 20, so minus 20 cos t centimeter. Thank you.